All right, today we are going to talk about dividing radicals and rationalizing the denominator. We already talked about dividing radicals in a very simple way, but we're going to take it to the next level. So first, just a review of the rules. This was the rules that we learned from the very first couple of sections. So let's do a couple of examples. So let's start with simple example. We want to simplify 2 root 15 over root 3. So in this case, it's very simple again. So 2 is outside, there's nothing to divide, but root 15 divided by root 3 is root 15 over 3. 15 over 3 is inside the radical, and 15 divided by 3 is 5, and that would be 2 root 5. And that's basically it. All right, next question. 9 root 24 divided by 2 root 18. All right, so let's go through that. This one, same idea again. So let's change root 24 to each of these ones. To make it a little bit simpler, we have to change it to the mixed radicals. So let's do that. So 9 is outside. Root 24, it is 4 times 6. Denominator root 18 is 9 times 2. Now the reason I chose 9 times 2, 9 is the perfect square factor of 18. We need to do that to simplify the radicals, and so as the square root of 24. Now we go through that. That becomes 9. 4 comes out. That becomes 2 root 6 on top. Bottom 9 comes out. Let me just do this again. So 4 comes out, 9 comes out, and you take the square root of that, right? So the bottom will be 2 times 3 root 2. Great. Now the next part to that is we're going to do the simplifications. So in this case now we can really simplify as we're doing this. So 2 divided by 2, that's just 1. 9 divided by 3, that is 3, and we have 3 left over out of all those numbers. Then we have root 6 divided by root 2, so that would be 3 times 6 divided by 2, and the final answer will be 3 root 3, and that's what would be it. Now it's important to actually realize that you could have also just done the, just as a side note here, root 24 divided by root 18. You could have done this. You could have done just say 24 divided by 18 inside the radical, and then you say, okay, can we simplify anything in there? Well, both of them, 2 goes into both of them, so that would be 12, and that would be 9. Okay, so we have square root of 12 over 9. What else we could do? Yeah, 3 goes into both of them. Great, 3 goes into 9 3 times. That goes into 4 times. So now we have square root of 4 divided by 3, and the square root of 4 is 2, and root 3 stays in the bottom. Root 3 like that. Right? So we could have done that and then incorporate this with everything else in front, and there's nothing wrong with that. It's just that if you simplify it first, it becomes easier. All right, next part is rationalizing the denominator. Let me explain what that is. In the world of mathematics, we do not like to write a fraction that has a radical in the denominator. All right, so remember, denominator is the bottom piece right here, the bottom part of the fraction. That's the denominator. Denominator. All right, so to get rid of that radical, we call it rationalizing, because square root or radical is actually an irrational number. So there is a technique to that. Let me explain. It is going to be an equivalent fraction. So let's take the 2 root 3. And to do this, it's a fraction. What we do is that you multiply top and bottom of this single fraction by the denominator, which is the square root of 3. And that's what you would do. Now, by doing this, we are not changing the value of that original fraction. We're actually root 3 divided by root 3 is just 1. This is actually a value of 1. There's nothing that's actually 1. So it's anything times 1 is itself. So we're not doing anything that is illegal. All right, so by doing this, so let's see what happens when you multiply and you just go through the process. So that would be 2 times root 3. You're multiplying just the fractions, how you multiply from grade 8 and 9. Multiply the numerators together, multiply the denominators together, and root 3 times root 3, which is root 9. But slowly you realize that we're going to start writing a little bit faster. Root 9 is 3. So root 3 times root 3 is just 3. And your final answer is 2 root 3. Now, 2 root 3 over 3. 2 root 3 over 3, it is equal to 2 over root 3. You can take out your calculator and you can do this, and it's guaranteed. It is exactly the same. All right, next example. Now, not every question is going to look like that very pretty. Look at this example right here. 4 root 27 divided by 3 root 72. Now, to multiply top and bottom by only the radical, that's what we usually do for the rationalizing the denominator. A fraction or a fraction that has only one radical in the denominator and is single, we just multiply by the radicals. You ignore the number in front. So really, if you want to do this, you multiply this by the square root of 72 by square root of 72. Now, here's the problem. The problem is that 72 times 27, that's just a big number. We don't want to do that. We like to simplify this fraction first, then we can rationalize the denominator. So I strongly recommend you do that first. This is not a very optimal way of doing this problem, so I'm going to erase this again. I just set it for the note so that you don't just do that blindly. So let's go through and simplify each of these first. To simplify, so now we're going to go do it quickly. 27 has got a perfect square factor 9, so that would be 4 times 3 root 3, because 9 times 3 is 27, so 9 comes out, that becomes 3, and 3 is outside. 72 has 36 as a perfect square, so that would be 6 root 2. So 36 times 2 is 72, so that would be. So now multiply 12 root 3 on top, bottom would be 18 root 2. Look, it's very now simple to do this because now we only have root 2 to deal with. So multiply top and bottom only by root 2. Now you could do it multiply by 18 root 2, but there's no need because at the end you have to simplify it again. So the simplest way is to multiply top and bottom by root 2. And when you do this, you will get 12 root 6 on top. The bottom will be 18, and root 2 times root 2, that's just 2. All right, and you get 12 root 6 divided by 36, and in this case you can actually simplify this more. 12 goes in 12 once, 12 goes into 36 3 times. If you can't do it right away like that, you can just do slowly, use a prime factorization. 2 goes into 12, 2 goes into 36, and break it down more. And final answer, root 6 over 3. You cannot simplify that. 6 and 3 you cannot divide because 6 is actually not 6, it's root 6. And you leave it as that. And that is it.